Hey, welcome to my channel Industry 4.0. Today, in this video, we would know the method to parallelize any characteristic logic with Python's multiprocessing module. Introduction. Parallelization in Python enables the developer to run several parts of a program at the same time. It is intended to decrease the complete processing time. The multiprocessing module is used to run free parallel processes. Those are run by using subprocesses in place of threads. It permits us to influence multiple processors on a machine. It means that together with Windows and Unix, the processes may be run in fully separate memory locations. In this video, we would know the method to parallelize any characteristic logic with Python's multiprocessing module. Description. We must divide the program into separate chunks of work to develop the full speed advantage from parallelization for the Python program. Each of those may then be given to different threads or processes. We'll likewise require to structure the application as the parallel tasks don't exceed each other's work. They also don't create arguments for shared resources, for example memory and input and output channels. Multiprocessing for parallel processing. We can well parallelize simple tasks by creating child processes. These may be attained using the standard multiprocessing module. This module makes available an easy-to-use interface. It consists of a set of utilities to control the task submission and synchronization. Process. We can make a process that runs independently by subclassing the multiprocessing process. We may initialize resources by extending the __init___ method. We can write the code for the subprocess by implementing the process run method. We understand how to create a process that prints the assigned ID in the following code. Parallelization in Python. We need to initialize the process object and raise the process start method to brood the process. In this scenario, process start would create a new process that will raise the process run method. Parallelization in Python. After p.start, the code will be implemented directly before the task completion of process P. We can use process join to wait for the job completion. Parallelization in Python. Parallelization in Python. Complete code. Import multiprocessing. Import time. Class process, multiprocessing process. def__init__, self, ID. Super, process, self, .__init__. Self.id equals ID. Def run, self. Time.sleep, 1. Print, I'm the process with ID, .format, self.id. If ___name ___ equals ___main__. P equals process, 0. P.start. P.join. P equals process, 1. P.start. P.join. Maximum parallel processes we can run. We can run the maximum number of processes at a time is limited by the number of processors in the computer. The CPU_count function in multiprocessing will display that how many processors are existing in the machine. Import multiprocessing as MP. Print number of processors mp.cpu_count. Synchronous and asynchronous execution. There are two types of execution in parallel processing. Synchronous execution. In the synchronous execution, the processes are done in the same order in which it was in progress. This is attained by locking the key program until the particular processes are finished. Asynchronous execution. Asynchronous execution doesn't include locking. Consequently, the order of results may get varied up, though typically gets done faster. There are two foremost objects in multiprocessing to apply parallel execution of a function: the pool class, the process class. Parallelization by using pool. Map. Map takes only one iterable as an argument. By setting the default to the minimum and maximum parameters to generate a new harmony_within_range_only function. It takes only an iterable list of rows as input. This is not a pleasant use case of the map, though it obviously displays how it varies from apply. #parallelizing using pool.map. Import multiprocessing as MP. #redefine, with only one mandatory argument. Def harmony_within_range_only, row, minimum equals 4, maximum equals 8. Count equals 0. For n in row. If minimum equals n equals maximum. Count equals count plus 1. Return count. Pool equals mp pool, mp.cpu_count. Results equals pool.map, harmony_within_range_only, row for row and data. Pool.close. Print, results, 10. #31444211333. For more details visit https://www.technologiesandindustry4.com/2021/12/parallelization in python.html.